Okay, so let's begin. Hello, everyone. Welcome to the Reuse Company webinars. You will be muted during the webinar. If you have any questions or comments, please use the question sections. And if you have any technical issue, you can use the chat box. This webinar will be recorded, and in a few days, we will send you the link to the recording. Today's topic is Unlocking Cross-Platform Potential, a deep dive into systems engineering interoperability. My name is Jose Antonio Donoso, and I'm from the Marketing and Communications Department, and I will be your host today. With me, I have Jose Pereira, Key Account Manager at the Reuse Company. For today's agenda, we will begin with a short introduction of the presenter and a quick overview of the Reuse Company. Then we will dive into the theory and the concept of interoperability, and after that, we will move to a more practical section where we'll review different interoperability examples. In the end, we will have some time for your questions. Today's presenter is Jose Pereira. Jose is an INCOSE ACEP certified professional. He is one of the main contributors to the INCOSE Guide to Writing Requirements. He is a key account manager and a member of the sales and consulting department under CCEP and ECEP. And he is the first author of a book that is dedicated to the application of a use case in systems engineering. So let's start with today's presentation. Hello, Jose.
Hi, Jose Antonio. Thank you very much for the introduction. Thank you very much, everyone, of course, for being here in this presentation. I will first, as Jose Antonio introduced, I'll first talk a little bit about the company, the Reuse Company, and then we'll proceed right on with the interoperability topic. So firstly, for those of you who don't know the Reuse Company, we are basically a tool vendor specialized in the application of semantic technologies and artificial intelligence for all of the different areas of the systems engineering lifecycle. Okay, we have been doing this for a couple of years now. We are gonna meet the 20-year milestone in not too long, and we've been doing this for software at the beginning, and then we pivoted into systems engineering when we discovered this immense domain with huge amounts of possibilities and potential to apply these semantic and artificial intelligence technologies. I will continue with the presentation on the company because I would like to discuss very briefly what intrigues us, let's say, what is the purpose of what we are actually doing. And I would like to just highlight 5 main pillars here. The first one is going to be systems engineering focused everything is going to be. So the first one is going to be technical management, right? Technical management, what we call the TMX. The X is for anything. Let's say we're trying to apply connections to almost any tool in the market today for systems engineering. So we want to provide with technical management on top of the connection to these different tools. Aside from technical management, we also have the possibility to interoperate, right? What use do we have on with connecting to different tools if we have no possibility to interoperate between them and have them interact between each other, right? Then the next one would be the famous requirements management or requirements engineering, right? So we call it the REX, and it's basically providing capabilities to the users for writing requirements with assistance, with in real-time quality analysis, so on and so forth. The next one is going to be, now that we connect to all these different tools, let's say we want to provide support for the life cycle of the system development throughout the entire VE model, okay? And finally, all this requires a lot of information and a knowledge base which is stable and fed by the information coming from the project and the needs of the specific company, right? So that's why we also have a pillar for knowledge management. Aside from the purpose, we connect, as I mentioned, to many different tools and platforms. Some of them, I wanted to highlight them here. The first ones would be IBM, IBM Doors, Doors Next Generation, Siemens Teamcenter, PTC, Dassault, Capella, Magic Draw, Cameo. These are some of the most famous ones. But as you can see, there's a mix, a sort of mix between requirements management, model-based systems engineering, ALMs, PLMs, so on and so forth. Of course, as we're trying to, let's say, aid on the process of systems engineering, we want to be compliant with international standards, and we want to provide you with the tools to be compliant with these standards, of course, right? So the most important one would be, as we follow in COSI, would be the 15288, of course, but we also follow through or can be compliant with other standards, such as the ones that you can see on the screen right now. And finally, I just wanted to highlight that we are following handbooks and guidelines, and we can help you apply these guidelines, right? One of them, of course, as Cecilia has already mentioned, is the INCOSI Guide to Writing Requirements, in which we are quite active in the contribution side, and we can help you, let's say, apply these pillars or these initial ideas, these baselines onto your projects without needing to enforce them at a complete level, let's say, right? You can tailor them, which is one of the most important things that you can do, is to not follow the handbooks and the guidelines strictly, basically tailor them to your actual needs, right? And finally, who is actually using our technology? Currently, we can highlight, let's say, 4 main domains plus a bunch of other industries that we have comprised there. The first one would be aerospace and defense. Then we have energy, automotive, and finally healthcare, right? As you can see, there are many big names on the screen right now. We can also include here some of the governments, but of course, these governments and additional entities would prefer to not have their logos here. So we refrain from that. But so that you can see that the application is at a, let's say, abstract and general level. Everywhere that you are applying or you are actually using systems engineering principles, you can use our technology. Now let's jump into the theoretical part of the presentation. This is going to be very simple. You will see the concept of interoperability hub. In order to understand this concept that we are, let's say, proposing here, I would like to go back a little bit and recap on the main different sources of information that we have in a project usually of systems engineering. The first one would be, of course, having textual requirements. These are the heart of the information in any systems engineering project, as many standards, legislations, and the documentation usually comes in a textual format, right? This has many advantages, such as the fact that you only require the language that you are actually writing the information in to be understood, right? There's no need to understanding a specific language or a specific set of code and rules. Simply by having the language, you know the information that you're communicating, right? But from these textual requirements or this textual information, we have derived with time, and now it is very popular, the concept of conceptual models. And these are basically representations that allow us to visualize the information that we usually communicate in textual format, right? And they give us a clearer picture on what we're trying to build, let's say, right? This, of course, comes onto the next level, which is the physical models. And these physical models basically are the translation of this conceptual model onto the real world, right? Is the approximation of these concepts and these abstract components that we have defined on the conceptual models onto a more, let's say, closer approach to the actual real world. So we are now talking about physical components. We are talking now about physical systems and physical subsystems, right? So with these 3 different sources in mind, we can see that, of course, in the market, there are so many different tools for each individual specific source type, okay? And this is what we call here at the Reuse company, authoritative source of truth. An authoritative source of truth is any tool in this case that is specifically dedicated and highly competitive in the sector that it's dedicated to, right? So in this case, for requirements management, you have plenty of different tools which have been developed specifically to cover the needs and wants of the users for requirements management, okay? But this is great in terms of complying or completing this specific work. When you're trying to connect everything as a systems lifecycle would want to, let's say, there comes a problem, which is that these nodes are usually isolated, right? More and more PLMs and ALMs are let's say, incorporating more and more tools into their environment, which is growing the limits bigger. But this is not, let's say, solving some of the most basic problems in terms of what happens if I don't have the specific tool for the purpose that you have designed within your environment, right? Let's say I would have to request the specific development, so on and so forth, okay? So here's where the concept of synchronized source of truth comes into play, right? The synchronized source of truth basically provides a common environment, a common platform to which all of these different tools can connect to, right? Once they're connected to this common environment, we can provide with additional capabilities such as interoperability, such as quality assessment, traceability, right? Once you have everything connected, it is easier to see how to trace the lines, how to analyze the quality of the overall project, so on and so forth, okay? So for the Interoperability Hub, let me highlight you very briefly some of the key points, right? Some of the main advantages that you have when having a common environment, right? The first one would be that, as you can see here, we have plenty of different tools. We have highlighted already that. But one of the important points is that having so many different tools, you would want to avoid having direct connections between one another, right? Because if you have connections directly between two tools, then the rest of the environment is not going to be, let's say, reactive to those changes, right? For instance, in this case, what you want to do is basically have this common environment connect to all of them, and then you have tracking, you have control of the different versions, the change management, all the different interactions that occur with a middle layer in between, okay? The next one is that you have plenty of different purposes combined. So you may have knowledge management, you may have documentation, you may have simulations, conceptual modeling, you have ALMs and PLMs, requirements management systems, and even software development tools, right? So all these different purposes sometimes can be a little bit different, a little bit difficult to interconnect between each other, right? The environments are vastly different, their purpose is highly different, then it is complicated, let's say, to connect them together, right? Having a middle layer eases this process a lot because you have only one standard common platform which connects to everything seamlessly, let's say, okay? For the next one, and this is of course something that can come for granted, all these different tools are great, they're tailored to the specific needs, but they're not cheap, of course, right? Having to toss not only the economic investment, right, but also the time and effort invested by the users on learning and knowing how to actually use the different tools is something that you cannot, let's say, afford in many cases, right? Why tossing a specific tool in favor of another one, which comes in a bigger environment, when you can simply, let's say, put this middle ground, connect to it, and then have the knowledge and the effort that you have invested by your users mainly be, let's say, used in the subsequent projects, right? Not having to toss all these investment, let's say, to the rubbish, okay? Then the next one is a very important one, and is impact and version management. I've already mentioned it briefly, but this is something key, right? As you already may know. If you make changes, right, within a specific source, you need to be able to know which is the impact in terms of the project at an overall scale, right, on the other different sources. So if I make a change in my model, I need to know whether or not this is going to be impacting my requirements or my, let's say, future developments, my design, or my, let's say, my physical model, okay? So all of this is important and can be done by having, let's say, this sort of interoperability hub. The same applies to suspect traces. When you establish different traces between the elements, it is important to be notified whenever you make a change, right? Whether or not there has been an affected trace, right? If you have to revise all of these traces, you must know which traces are being affected by the change that you have performed in any of the sources, okay? And finally, the last one is going to be working also inside the common environment. The possibility to modify inside all the different sources is always going to be great because this, as I mentioned before, these tools are tailored specifically to their particular domain, right? But you can also modify inside the Interoperability Hub by means of interoperating, transforming, changing and saving information onto another source, so on and so forth. We can see a couple of examples later. But the idea is that you can make these changes and you can propagate those changes back onto the different sources, okay? So before jumping onto the different use cases, I'm going to highlight the 3 types of interoperability that we are providing. The first one is going to be very simple. It's moving or copying work products. And this is basically a generic name because the idea behind this is basically not modifying, not altering the nature of the elements that we are dealing with, right? So if I have an input, as an input, a textual requirement, the output is going to be as well a textual requirement. For the second type, this is going to be transforming work products. In this case, we're dealing with a bit of a different scenario because now we are indeed modifying the nature of the elements. So for instance, we can, one of the examples that we show later, we can transform a set of requirements, textual requirements, onto a conceptual model, okay? And finally, the binding of work products. In this case, we are basically linking two elements, right, on 2 different sources, and we are basically configuring that if a change occurs on the source side, then the target is going to be modified in X way. Okay, this is something that we can tailor and we can adjust to the specific needs. So for the first example, let's jump onto operations. And let me fill you in a little bit on the current situation. We are actually inside an MS Word document. And as you can see, we have another tab, which is the SES Engineering Studio, which provides us with the possibility to have 2 views. Let me highlight you here. The left-hand side is going to be the original, the common Word documentation of view, while the right-hand side, as you can see, it's more of an engineering view, right? We can see here all the different requirements with the IDs specified. This is what provides you the SES Engineering Studio inside MS Word. What we are doing right now, as you can see on screen, is basically connecting to another source. So we have already connected to Word, which is the one that we have opened right here, and we are right now connecting to IBM Endorse, okay? In this particular case, we are connecting to an empty module within a project. And what we want to do is, for instance, let's imagine that we have a specification within the MS Word document, and we want to bring it back onto Doors because our experts are in Doors, they're not used to managing the information and working with requirements inside MS Word. Okay, so as you can see here, we select the source and we select the target. In this case, the source is going to be the MS Word document, and the target is going to be the Doors module. We simply define the interoperability, and we can just go ahead and execute it. As you will see, this execution is not, let's say, straightforward. You're not just pushing information. You can see here that we can select which side is going to be the master. So from which side we are pulling the information. And right now, as you will see, if we select the option OK, we move on to another window, right? And the window that prompts and opens is a window showing us all the different sides. Let's say both sides. Side 1, which is in this case the MS Word, and side 2, which is going to be the Doors project. Okay. Let me jump a little bit back because I would like to show you here something else. This is the action side. In this case, by default, the tool is programmed to, if you detect a specific element on one side, on the master side, and it is not appearing on the other one, the by default option is going to be to create the item new in the second side. But here I could just drop down this list, and I can select the option to not propagate this specific requirement, for instance. Okay, we'll later see that you have also the option to synchronize and to bring the updated information to the source, let's say, that we want to bring the information to. Okay, so we are now executing the process. And you can see here that the state in the repository has been already updated. Very good. And all the different requirements that we have included are now in state new. Okay. The next thing that we are going to do is to save. By saving, we are not only saving within the SES Engineering Studio, but we're also pushing the information back onto the source. As you will see right now, we will open the Doors project. Here it is, the module. And this module that was previously empty, if you remember, now it's filled with all the different requirements that we had within the MS Word. Now, the idea is that my requirements engineers are now working, which are experts on Doors, by the way. They're working inside Doors, they're modifying the requirements, they're changing them, they're including new ones, they're removing older ones, so on and so forth, right? Then let's make a couple of changes. And we're going to include as well a new requirement. Perfect. So now what we want to do is to, let's say, synchronize back the information from Doors and to bring it onto the MS Word document. So we'll proceed to connect once again onto the Doors project. The credential side can be actually configured to be only requested once, right? The first time that you connect locally. And in this case, as you will see here, the state in the repository is updated for the entire module. And this is basically due to the fact that we have one requirement which has been updated and another requirement which has been included, right? Which is new, okay? So now we can simply, using the same interoperability that we had before, we can execute it and synchronize back this information onto Word. Now, the master side is not going to be the first connection, which is the Word one, is going to be the second one, in this case, the Doors. You will see now, let me just, okay, stop it right here. You can see the master, now the Doors project, has the requirements with the latest changes, okay, because we have been working on the authoritative source of truth, and now we are bringing the information back onto the common platform or the common environment of the Interoperability Hub. So on the second side, the requirement had 2 Peltier plates, and in this one, the new updated version, we have 4. On the side of the MS Word document, we did not have this requirement, and now we actually want to include it. So the actions by default, the two, as you can see, we have not changed anything. By default, the first one is going to be to update the item using the latest information, the master information, and creating the new item on the side which doesn't have it. The option could be as well to simply select not making, not performing, or not bringing the updated information onto the second side. Now, as we have selected the option to update and to include, the corresponding requirements will have their status modified accordingly, right? So updated for the corresponding one and new for the newly included one. As you can see here as well, the information is already updated within the Doors, within the MS Word document, sorry. In this case, as we select the latest, the newly included requirement, we can see here that on the documentational view, let me highlight it for you. We can see here that the requirement has been included and it's already highlighted, okay? Perfect. So we move on to the second type of interoperability. If we remember, now we're dealing with the transformation of work products, which basically means that we're altering the nature of the input onto the output. So in this use case, basically what we will be doing is we have the requirements that we have been working on within Word. And now what we want to do is basically to transform them onto a product breakdown structure. So we want to have these textual requirements moved onto a Cameo model and collectively, let's say, build the product breakdown structure with the relationships between the components as well as a state transition diagram. Okay, so we are right now on the same view as before. Remember engineering view and the documentation of view. And now what we will basically do is, let's say, as you can see here, we can click on the different elements and these are highlighted automatically. This is what we were showing at the end of the previous demo. And now we have the connection to a new empty, completely empty Cameo model. Okay. Oh, sorry. Here we are. Very good. So we have simply opened the connection, right? As you can see here, the Cameo connection has both elements in new for the repository because these were not registered previously. And this is basically the overall project and the folder that comes by default when you create a new project inside Cameo. So we save all the information and we'll now proceed to, as we have done before, we'd have to define the interoperability activity, select the source, in this case, the MS Word document, and the target as the Cameo model. And we would have to select specifically the type of activity that we want. So in this case, would be a transformation type activity and would be generating a SysML model from a textual requirement source. Okay. So we're simply going to execute it. And here, there's a very interesting option. As we're transforming and generating a model from a textual source, we can simply generate during the process the traces that comes with this transformation. Okay. So as you can see here, we're highlighting basically that the elements, the requirements that are specifying a state or a component have the corresponding or the consequent element defined within Cameo. So you can see here now all these elements are created new. The relationships between the components of the product breakdown structure and the different elements, of course, the different components, subsystems, and the overall system. Within the system, you can also visualize here the different state or modes of the state transition diagram that we will also show later. Now we save as we have done before. We push all the changes not only within our knowledge base and our ontology in the SES Engineering Studio, but also directly onto the Cameo model. As you can see, all the components have been created. Within the system of interest, we also have the possibility to see the states for the state transition diagram. And we can even build it automatically with all the relationships already established. Okay. So for the last and third type of interoperability, this is going to be the binding of work products. So in this case, we're basically going to be modifying one side and triggering a specific change on the other. So now, as you can see, we have, as before, we have two sides. On the left-hand side, we have the Cameo model. As you can see, we have been working on it. Our engineers have been, let's say, including more components, more relationships, more status for the state transition diagram. And on the right-hand side, we have an Excel file. In this case, it could be any other requirements management system. And this side includes all the different requirements for the specific subsystem or component. Let me just bring it back a little bit. Okay, so here we have all the different requirements, system requirements for the specific subsystem. In this case, it's going to be the control subsystem. And as we have it here, we have the component and we have all the different requirements. We have been, let's say, doubting on the specific name, for instance, in this case, and we're not 100% convinced of it being control system in the latest version. So what we want to do is we are gonna bind, which is the symbol right here. This is the binding state. This indicates that you're transmitting some information, right? And what we want to do is we want to bind this component to all these different requirements, right? This is a very small sample, but this can be applied to very large samples as well. You can bind it to all these different requirements so that whenever we modify the name of the components inside the model, right? So if I change the control system for another name, it is automatically triggering a change on all these different requirements, right? And it's intelligent enough to know that the control system is here in this part of this specific requirement, but here we have it on this side, right? It's after the A condition. So let's see that we have already configured, as you can see here, all these icons indicate that this is a receiving side of the binding transmission. So we can modify here the name. So in this case, the last name is going to be management system, or the next version is going to be management system. And as you can see here, all the requirements are modified accordingly to the new name. Okay, very good. The only one that has not been modified is the first one, because we have not created a binding for it, which is what we are going to do right away and show you how to actually create this process. As you can see, as you will see, it's very simple, but you have to, let's say, have some sort of configuration prepared. Okay, so we save the information. Right now, all this information is going to be not only saved inside the SES Engineering Studio, but also pushed back onto the source. So for the process, we're going to select the option to start a binding. It's going to be highlighted now. And now we're going to go onto the other side and select the option to finish the binding process. Okay. Now we're going to be prompted with this huge window, which is basically comparing both sides. But what I'm interested in is basically the addition of a new binding. And now, very simply, I'm going to link the content, right, on this specific attribute, which is going to be the name, and the content on this specific attribute, which is the description of the requirement. Now, for the requirement, I'm going to be a little bit more specific, right? And I want to tailor the connection to actually define a pattern. A pattern, for those of you who do not know what we refer to as pattern, is basically a structural template, which, as you can see, is comprised of the different blocks that a requirement must have, let's say, for us, right? So in this case, we're selecting this specific part within this structural template that corresponds to the component that we want to alter or modify whenever a change is completed on the model side, okay? So in this case, if we modify the management system, then the control system would be modified, the management system here would be modified as well, so on and so forth, right? So in this case, we decide to roll back onto the previous version, changing it onto control system. And as you can see now, all the different requirements are including the control system name, right? Another thing that we can do, and this is very important as well, is the version management. As you can see, I can simply right click, select the show version options, and I can see here that one of the previous versions was hidden system. It might have been a mistake, or it might have been a design decision, right? But in this case, I estimate, or I discuss with my colleagues, and I estimate that this version was the appropriate one, and then I want to revert back to it. And as you will see here, it has already been modified. So once I click close, the requirement is back onto the previous version, okay? So with this, we would conclude the last of the 3 types of interoperability. And with that, I would like simply to lead on to the questions and discussion section. Do you agree with this concept, with this idea? Did you find it useful, or did you find more easy to use further alternatives? Which is your overall experience on this topic.
Thank you very much, Jose. He will answer your questions in a minute. So if you want to ask him anything, please write down your questions in the question section. So in the meantime, we can discuss our upcoming webinars after the summer. Okay, so many interesting topics are coming. In the first place, the new version of the INCOSE guide is being released in July. And as you may know, we are contributors and we've been working to implement new rules and patterns to the guide. Along with INCOSE, we will provide a webinar to revise these updates and we will show you how you can apply them to your projects. Besides this INCOSE guide, we will host a 15-minute webinar in which we'll explain the importance of avoiding negative voice when writing requirements and how our tools can help you do it.
Okay, thank you.
Okay, so back to the questions. We have two questions. So let's start with,
okay, great.
How can you manage and control the modifications performed on one side so that they are not immediately overriding the other and causing more potential issues?
Right, thank you for the question. I think this is, of course, a very important topic here. For the use case, we basically showcase which are the overall capabilities, right? So, for instance, the binding, there's absolutely no control in the demo, let's say, or in the use case of whether or not you can make or perform a change on the source side mainly. But we have the possibility to control that by using something which is the change request capabilities within the tool. And this basically, aside from the possibility to grant you permissions or not to modify elements on the, let's say, on the source side, these modifications, when you enter the change request mode, basically all the changes that you perform are not saved within the source, are sent to the corresponding responsible, who is going to evaluate these modifications and is going to either approve or deny these modifications, right? So in the case of the bindings use case, imagine that I was actually in change request mode. I would perform this change from modifying the control system onto management system. Then this change would be sent onto my responsible, the person who's going to be actually taking the decision of whether or not this change goes through or not. And then is going to send back a response, whether he accepts it or he denies it. And if he accepts it, then the change is going to be propagated to the other side. So there is a way to control in this manner the modifications and the propagation of these interoperability capabilities. But also, there's always the possibility to just control the access to it. You can define a read-only mode. You can define, let's say, no access at all, so that the person cannot see even the connection. And once you have modification permissions, you can, let's say, get into the change request mode, as I have mentioned previously, and control whether or not the modifications are what you expect or you would like. Okay. So thank you for the question. I think it's quite an important topic as well. Even though these are some powerful capabilities, they need to be regulated to not just go on by and make changes whatever and whenever you estimate to.
Okay, on to the next question. Do you support Doors Next or Vitec Genesis?
So DNG, we have been working with DNG. We have an actual plugin, and we have just finished the development of an agnostic version of our wrapped authoring tool. So this tool is basically capable of providing you with assistance, let's say, to the writing process and in real-time quality analysis. And as it works on top of agnostically on top of any, let's say, Chrome tab. So you can actually open their Doors Next Generation and you can work with it. With regards to the interoperability, we are not, let's say, we have connection to Doors, but not connection directly to Doors next generation. This is something that we have already within the roadmap, of course, but we'll be developing in the next couple of months. Okay.
Okay, on to the next question. Do you have a comparison of MBSE tools in terms of interoperability?
Could you please repeat the question, please?
Yes. Do you have a comparison of MBSE tools in terms of interoperability?
Yeah, I think we have this is something we should let's say we have worked on the comparison between requirements management tools. As you have seen, we are very much keen on the idea of working with MS Word. We have compared it to tools such as Doors, for instance. But in the MBSE domain, we are aware that there are some tools that are actually providing interoperability. But this interoperability is always between, let's say, the source tool and something else, right? Let's imagine, or let's say that I would be talking about MS Word. So this interoperability would always be between MS Word and something else, between MS Word and Cameo, MS Word and Capella. But what if, let's say, I'm receiving, for instance, a Cameo model, and then I want to, let's say, transform it onto a Capella model because my provider or my supplier works with that, or my team works better with that because we have a couple of experts, right? So there's certainly the integration or the interoperability between source tools, which are developed by them, let's say. It's going to be more integrated, right? But it's going to be limited by having always either the source or the target that specific tool, right? The option or let's say the key advantage of having a common interoperability hub is that you can connect with whichever, as long as we have connection, right? So Doors next generation is coming in the next couple of months. You are able to connect to them and to connect to other source or another target, and then you just perform interoperability. You're not limited by the source or target that you're choosing or you're picking, right? Hopefully I was able to answer this question properly, because I think it's quite an interesting one as well.
Okay, and the last question. What software needs to be installed and where? At a guess, you have a database, a local application, plus some add-ins in the various tools.
A wonderful question as well. You basically need, in this case, the SES Engineering Studio, and you would need the capability for interoperability, right, which is an additional capability. And then once you have that, as you mentioned, you have the server, which comes within the package. It's completely free. And with the server, you are able to connect to your database, right, your ontology, where you will be able to allocate all your knowledge base for the project. And then once you have all these three key points, you're basically able to connect to all the different sources, right? Sometimes our clients, our customers allocate the server within an internal server, and then they place, let's say, the SES Engineering Studio locally on different user sites, or they actually allocate as well the SES server on a server itself, and then the users can connect to it, right, using the different users and passwords that you can actually create and configure. And basically that's it. You would not require even a plugin, let's say, within most of the tools. There are some of them that actually have a plugin, but this is mainly because you would want to have SES Engineering Studio within the tool, right? So for instance, we have an SES Engineering Studio for Capella, and you basically have SES Engineering Studio within, let's say, Capella. So it's having, let's say, the next step. If you only want to have, let's say, the common environment and the interoperability hub, you can have the application and you can connect directly to a Capella model or a Cameo model, your requirements management systems, your ALMs, PLMs, so on and so forth, right? As long as you have the credentials, each connection is adjusted, right? So for instance, Doors, you have the user, the password, and you can select the project and the different modules that you want to connect, okay? But as long as you provide the let's say, the URL or the direction or the server address, then you're good to go. Okay.
Okay, so no more questions. I think we've covered them all. That would be it. Thank you very much, everybody, for attending. If you have any additional questions or want more information of our tools, don't hesitate to contact us by email or to our website. We recommend you check out our YouTube channel for more videos of our tools. Thank you very much and goodbye.
Thank you very much, everybody. Have a good day.